Good day, folks. Welcome to Bright Mind Academy, where we bring brilliance to every lesson. In today's video, we're gonna continue from where we left off. Remember the last video we did, uh, determining the equation of the given graph as well as sketching the graph of the given equation. All right. In this video, we're gonna go into further detail on our hyperbola function. I avoid saying hyperbolic function because in university, hyperbolic function means something else because it is where we deal with trigonometric graphs. But yeah, either way, we are not there. We are in grade 12. So now, grade 11 and grade 12, respectively. So now, what are axes of symmetry? This word you have heard it from grade 11, grade 10, where you were taught what is an axis. But either way, let me just assume that you know anything about, you know nothing rather about axis of symmetry. So if I'm having my line here, remember I'm still talking about the function of hyperbola here. Let's say I have, right, it's fine. For now, please just bear with my skewness for now. I'm trying to explain something here. Remember, we have a function like this, maybe a asymptote here, another asymptote by maybe there. Right, so we have our function here. Here's our function maybe, and the other part of my function. All right, now this is what we have already learned. Again, we know these lines, dotted lines, our asymptotes again. But now we're going to talk about symmetry, axis of symmetry. Now, what is the axis of symmetry? Axis of symmetry, it is a line that cuts our graph into two. So check from this point here. Normally, I teach like it. Here, I teach it like this. From this point from the point of contact of my asymptote, I go down to cut my graph here, and I go up like this to cut my graph there. So you see, this is skewed like this. So you see this line here. This line cuts my what? My graph into two, but we have two as a symmetry, axis of symmetry here. This is the first axis of symmetry. This is the first axis of symmetry. We also have the second axis of symmetry from here going that way. All right, like this. So they are like this. We have two of them. But what's unique about them? What's unique about them, you can see this one here. It is slanted forward. Akira, it is like this. Akira. So it tells you if it is like this, it is an increasing. It is an increasing function, straight line. It is an increasing straight line function. So it means it has y, it is equal to mx plus c. Where the value of m here, the value of m here, it is positive. You agree? Then when you come to this one, it is slanted backwards like this. So it has a negative gradient. Again, sorry. So it means it is y is equal to negative mx plus c, where we say our m in this case it is less than 0. All right. But now m, take note of this. Take note of this. M is always equal to 1. The value of m, the magnitude of m, the m here, it is always 1. The m here, it is always 1. It means here, the gradient for this one, it is 1. But for gradient, the gradient for this one, which since it is negative, it is how much? Negative 1. These are the gradients. It's either it is 1 or negative 1. What exactly am I trying to say here? I'm saying here, it means now the equation for this straight line, it is like this. If I were to rejuvenate it and renew it, it's going to be y, it is equal to x plus c. Why? Because the gradient here, it is positive. It means for this one, it's going to be y, it is equal to negative x plus what? Plus c. Why? Because now our m it is wrong, it is -1. All right, so this is the equation of the axis of symmetry with a positive gradient. Positive gradient. This one is an axis of symmetry with a negative gradient. Negative gradient. Now, sometimes the examiner will say that has with an axis of symmetry where m is less than 0, or axis of symmetry where m is greater than 0. But remember, you're watching YouTube so that your life can be easier, right? So let me make your life more easier. Let's come to this page. Let's say now we have this equation. Y is equal to 3 divided by x minus 1 plus 2. And maybe our graph, it is like this. Maybe you're given that graph, let's see, or you're required to draw it, whatever the case. That might be them. So I know my sketch is going to be like this. This is positive 2 here. This is 2 and -1 maybe here. This is going to be positive 1. So, and maybe my graph, this is positive quadrant 1 and quadrant 3. I do not care about other things. I know my axis of symmetry is going to be more or less something like this. The first one. And the second one is going to, from the point of contact, is going to be like this. Again. So these are my two axes of symmetry. So now let's say now the examiner said to us, determine, let's say the examiner said to us, determine the axis of symmetry with a positive gradient. What your teacher might teach you is that you use this equation. Since well that axis of symmetry is a straight line, you use this formula mx plus c. Alright? But you know that your c, it is what? Your m, but your m, it is equal to 1, because why? We want with a positive gradient. Again. So with a positive gradient, you know your y, your m, it is equal to 1. So it means you have y, it is equal to x plus c. Therefore, you have to find the value of c first. Again. So how do you find the value of c? You take x and y coordinates from asymptotes. Why am I saying you take x and y coordinates from the asymptote? It means you have to come here and see what is the equation of your asymptote. Or maybe you might be given a point here. Remember those two lines, they both pass here. So we are talking about this one with a positive gradient. So you're talking about this one. So the coordinates of A here, which is the point of contact, let's say this is A. What are those coordinates? I come here, I say, all right, it's going to be 1 and how much? 1 and 2. Let me do this. 1 and 2. So I'm going to take that point, the point of intersection. So I'm going to say my y, it is 2, then my x, it is 1 plus c. Therefore, c, it is equal to how much? When I take this to the other side, it is 1 again. So therefore, my equation with the positive gradient, it is how much? X plus 1. This is my equation for the axis of symmetry with a positive gradient. But I'm going to come and make your life easier. Now I'm going to come here and make your life easier. How? I'm going to say to you, my grade 11 and grade 12 learners, do not stress yourself about anything. If you are required to find the axis of symmetry with a positive gradient, come here. Whether positive or negative gradient, come here. Take this part. Let me change my highlighter. Take this part. Like this. Actually, let me do this. Take this part. Take this part. Paul, what am I going to do with that part now? Because they want me to calculate the axis of symmetry. Yes. Or this is axis. This English axis like this of symmetry. How am I going to use this now? Remember the answer that we got here was y it is equal to x plus 1. Take that in mind. Okay. So what you're gonna do with this, if the examiner says with a positive gradient, you're just gonna say y it is equal to positive gradient. You take this as it is, the bottom part. This is positive. You take it exactly as it is. Okay. With a positive gradient, it's gonna be x minus 1. Then and put a bracket plus 2. Then do your math. Y it is equal to x minus 1 plus 2. Then y it is equal to x minus 1 plus this. It is plus 1. Your math is done. Easy math. The answer is the same. Y is equal to x plus 1. All right? Now, let's say now the examiner said we have proven this again is the same. Let's now change the question and assume that the examiner said with a negative gradient. So we know with the negative gradient is going to be y is equal to negative x plus c. Or rather, let me start here, negative mx plus c. Negative gradient, this is negative again. But m it is equal to 1. The magnitude of m it is 1. So I'm going to substitute m is equal to 1 is going to be negative x plus c. Again, so now how do I find the value of c? Find the value of c, I have to come here and find my what? This coordinate, substitute this coordinate of substitute the coordinates of the asymptotes. Yes, asymptotes, which is what in this case, what is my y? My y it is 2. My y it is 2. My y it is 2 negative. What is my x? My x it is 1 plus c. Therefore, what is my c? Therefore, my c it is equal to, when I take this to the other side, it is 3. Therefore, my equation it is y is equal to negative x. Remember, it is a negative gradient. All right, negative x plus what? Plus 3. So we see our answer here, right? So let's take our answer. Let's take our answer and put it. Never mind. We know that our answer it is y it is equal to negative x plus 3, right? So now let's try this method of mine that is very nice and easier instead of using the longer one. You are finding the equation of the axis of symmetry. So you're gonna say y it is equal to, but in this case they want with a negative gradient. You just put your negative here in front. Then you take this part, you put it inside your bracket, x minus 1. Then this is plus 2, exactly as it is. Plus 2. Then you solve, you become a mathematician. Negative x multiplied by, or negative multiplied by this, it is negative x. Negative by negative, it is plus 1. Plus what? Plus 2. Therefore, y it is equal to what? Negative x plus 3. Is this not the same as this? It is the same. So please, use the method that is best for you, but I prefer you to use this one because it is more straightforward. All right, unless the examiner has specifically required you to use y it is equal to mx plus c, then if that's the case, you can use the method, this one. But if the examiner did not tell you anything about which method to use, you use the one that I've taught you, or you choose between the two. All right, or the easier method that you understand, but taught to you by your teacher. All right. I wanted to explain this and what. Oh, and the last part. I want to believe the axis of symmetry has sunken. Yes, if something has sunk in past tense, sunken. Yes, the English is nice, man. I want to come here and say if I have a graph like this. Let's say I have my asymptote here, as well as my asymptote there. Then I'm having my graph somewhere here. and my graph somewhere here. All right. And now the examiner has given me the, can I change this color? Which color should I change? Yeah, this. And now the examiner has given me what? Let's say the examiner has given me the axis of symmetry. That has a negative gradient here. Like this. This should be a straight line. All right. So let's say the examiner has given me, this is the axis of symmetry with a negative gradient. Let's say y it is equal to negative x plus c here. All right, let's say plus 1 maybe. Then let's say our point here, our coordinate here was 2, and our coordinate were let me see another point that I might need, or here. But this one cannot be positive 2, negative 1. Let's say maybe here this coordinate here it is 3. All right, there are these questions that the examiner likes to ask. Hey, the examiner might say to you, the first one, let me say determine the value of x for which number 1, let's say this function it is given as f, for which f of x is greater or equal to 0. These questions we should not neglect. So the examiner is saying to us, determine the values of x for which the graph is greater or equal to 0. So now, how do I interpret this question? This question interprets as follows: determine the values of x for which the graph for the values of x for which the graph is equal to 0, the equal sign here, equal to 0 or above 0. Above or greater than 0. I know the graph is equal to 0 where? Here. This is my x, this is my y. I know my graph is equal to, the x values of my graph is equal to 0 where? Here. My f of x is equal to 0 there. All right? Or greater than 0. Greater than 0 means above. Above. This means above the y-axis. Let me write it neatly. Above the y-axis. Above the y-axis. So let's try to answer this question. Let's try to answer this question. Where is our graph? The graph of f is this one again. We agree the graph of f is this one again. So where is that graph equal to 0? So we know our graph equal to 0 at here. Okay? We have a answer to this first question. Our graph is equal to 0 at x is equal to negative 1. Where x is equal to negative 1, our y, this is our y. Our y it is equal to 0. Okay? Or it is greater than 0. Greater than 0, it is above the y-axis. This is the y-axis. This is below the y-axis. This is above the y-axis. So where is our graph? This graph of f above the y-axis. We agree it is above x-axis here. But until to this point, so it is from negative 1 up to, let's say here, we're given this coordinate as 2. So it is from this point negative 1 up to the point where it does not reach a whatever value, but it does not touch 2. So it means between this point negative 1, this point negative 1 and point 2, our graph Here it is equal to 0, but here it is like this. But remember here it does not touch this graph again. So it means our graph is between our graph is greater or equal to 0 between this which point -1. You can see it is between which point? Between this point -1 and 2. You all agree? Between -1 and -1 and 2. But now, as I answer this, I'm going to say, therefore, x is an element of between what? I'm going to include this -1. Why am I including -1? Because my graph touches -1 here at this point. We agree? And the examiner has said equal to -1. And between -1 and what? And 2. Between -1 and what? -1 and 2. But the question is, will I include 2 here? Will I use this bracket or this bracket for 2? But the answer is I will use this bracket, close bracket. Why? Because my graph does not touch 2. So if my graph does not touch 2, it means I have to exclude 2. It means my graph it is between -1 and 2, but my graph does not touch 2 or does not reach point 2, but at -1 it does touch. So I hope you understand what I'm trying to explain here. I hope you're trying to you understand what I'm trying to say here. But someone might say or use this method of saying it is between -1. -1 it is included, but less than 2. 2 is not included. Number 2, let's have a question. Maybe the examiner said it is a between, or let's say the examiner said f of x, let's say just f of x is less than 0. F of x means determine the values of x for which the graph of f is below y. Below y axis. Let's take our highlight. Below y axis, it's here. Remember, the examiner said less than 0. So it is here, it is 0, we know. Then from here, it is less than 0. Why? Because it is the below y axis. Again, we agree. Then also our function, it is on this portion, it is also below what? Below 0. We agree. Whereas this part we said it is above. So how am I going to answer this? Look at the difference here. The examiner did not include 0. So it means when you answer, you should not include this or you should not include this, depending on the method you use. So let's answer that question. The first interval that I see is that from -1 here, going to the left, my graph is below. I agree. Do you agree with me? From -1, from this point up to -infinity there, my graph is below 0 for this portion. So I'm going to say the first one is x is an element of from -infinity to what? To -1. Why am I saying -infinity? Look, remember here it is -infinity. My graph it is still below until it reaches that -infinity. So it is between -infinity and -1. We agree. This is between -infinity and -1 there. All right. And remember, we start with the lowest value and highest value. Remember here it was -1, lowest, highest. So now I'm going to say -infinity to -1. Now -infinity, we never include it. Even if the examiner said equal, we never include a -infinity there with a square brackets like this. It is always open bracket or round bracket. All right. Why am I not including 1 in this case, whereas in this case I included 1? In this case, I'm not including 1 because why? The examiner said below 0, not equal to 0. In this case, I'm having only one scenario. Here was the graph is equal to 0 due to this equal sign, as well as greater than 0 due to that sign above here. But in this case, I only have one inequality sign, which is less than. So it means I only consider where it is below y-axis. So I'm not including -1. Why am I not including -1? Because at -1, my graph it is exactly equal to 0. But now I also have another portion. Which portion is that? This portion here. This portion of f, it is also below Leona. So if it is below Leona, I'm going to say, all right, n, or my x, it is between what? Now let's check this portion, it is between what? This portion, it is between 2 here, we agree, and positive infinity. This is positive infinity. We agree between 2 and positive infinity. My graph is below 0 again. Yes, but now remember, it does not touch 2 at all. It does not touch 2. So it means I'm going to say it is between what? It is between 2 and what? And infinity. Remember, infinity do not include. So these are our intervals for this particular case thereof. Or someone preferring another method can say x, it is between negative infinity, negative infinity and infinity and negative 1, or x is between infinity and what? And 2. This is normally your 3-mark question, so never neglect them. I believe you are following. So yeah, I think that's all for anything that relates to explanation of hyperbolic function. I think the next video will be tackling now exam questions and seeing how these questions are structured thereof. Thank you very much. And if you enjoyed the video, please kindly subscribe to our YouTube channel so that you can see more videos that are going to follow, whether you're doing grade 12, grade 11, grade 12, or you are upgrading your results. Please subscribe to our channel so that when we do question papers, you will not be left behind. All right, thank you very much, folks. Until we meet again, thank you.